start. Come on, Landon, you got to let me know. Okay, I'm ready. Do we have sound? We have sound. Okay, so the last bit. What's the probability of being between 50 and 51? You're going to answer this the same way that you answered questions like this before spring break. Draw on here 50 and 51. Shade. Make a mental note as to how much of the distribution it looks like is shaded. It looks like it's maybe 30%. It doesn't have to be perfect. Just a mental note, because you want to have an idea before you do Excel. Now that I've got all of that, let's see what the Excel is going to tell me. So I'll type this into Excel. Let me make it so that you can see the iPad again. Boop. No, I did the wrong one. I clicked the wrong window. Let me try again. Wait, where is the iPad? iPad's not, oh, it's because it's full screen mode. Okay, I'll just deal with it. There we go. Here's what I'll do. Oh, you still can't see it. It's back there. Okay, sorry. It's like a feeble person trying to use technology. Just a sec. I'll move this. Just move this over like that. There we go. There. Now we can see it. And you can kind of see the shading. I guess I could always move that over as well, couldn't I? There. It's kind of like that. There. That's what we're looking at. And so what we'll do is we do, first of all, less than, you don't have to type all this in. I just want to make sure that you understand what I'm doing. Less than 50. So because of this problem with Excel being leftist, we have to always think in terms of areas to the left. And so when you do that, you do equals norm.dist, and then we have 49.8, oh no, 51, 49.8, what is it, 0.768, and true. So that's going to be the area to the left of 51 from here over. And then the area to the left of 50, since I've already typed all that, there's no sense I should type it again. I'll just copy it, paste it, and fix the number here to be 50. And then subtract the two from one another. Top one minus the bottom one. Oops, I went the wrong way with that. Well, let me fix that. B1 minus B2. There we go. 33. I was almost right. I guessed 30%. So 33.81% apparently is the right answer. But you would do the same thing. Whoever it was, Clayton's going to do the same thing when he gets to it on his homework. But if you're stuck, that's what you're going to do. If you're doing the quiz for me, you're going to do exactly the same thing, only you're going to use the numbers that I've given you in the table here in lieu of pulling up Excel. Now here's the little glitch with the quiz, is either out of being mean or out of wanting you to actually understand that there are two different types of problems that we've gone over that require you to do this sort of thing. I have both of those here. On the top, so I'll even tell you this, on the top I'm only interested in the probability of a single observation. So in other words, if I was just interested in the probability that a single play of this game lasted between 50 and 51 minutes, then I would use the old standard deviation. So use the original standard deviation for the top one, because you're only interested in a single observation of whatever stupid thing, fuel economy for cars. And then on the bottom, you're going to use the new standard deviation. Okay, you can do this. Okay, any other questions, concerns, fears, worries? All right, well, if not, let us do this. It'll be fun. I'll pass it around and then I'll put it up on the screen for anyone who's not here. I think no one's not here though. Well, here you go. You can have a couple. Maybe I'll put it up there in case you want to relive the magic. Three. 1, 2, 3. I think there's 3 there. I don't know. If not, you can yell at me. There's probably not enough words. One more. Who else is hogging them? No one else? Come on, someone's got an extra. No one wants to admit it. Okay.
Let's see. There, finally. Yes. You're going to put the mean and standard deviation of the news. Yep.
That's fine.
All right. No rush, I'm coming back. Very good. Very nice. You see how that works? Oh, you got it right. What is that? Good. All right, let's see who else we got. Done? Done. Done? All right, good. All right, let's do this. Are we all done? We're all done? I've got them? I've got them all. So, good practice for our next test. Holding out on me, I see you. We're holding out, it's okay. Let's do it. So, good practice. Look at, oh my goodness! I had forgotten that they didn't erase this. Here it is. So, these are the answers for the mean and standard deviation of the sampling distribution for means. Let's just go ahead and see how this looks. Oh man, why does it do this to me? Okay, that's the best I can do. Let me show you there. Okay, so my first one, I drew the little picture. I'm doing a single person, so I just used the basic information given, and so that's going to be this right here, I think. Did I circle the right one? I think that's the right one. Oh, something weird happened again. But anyway, and then I had to subtract from 1 because I was interested in this stuff over there. Excel gave me this stuff over here. Okay, so for the next two, sorry about the little mess here. This is 34.7 because the mean of a sampling distribution is the same as the mean for the population. So the 34.7 I put there in both of those slots, and then the standard deviation changes by the square root of n. So here I divided by the square root of 10. I know that's ugly, but I did my best. This one was a little nicer because I could just write 5. That's the square root of 25, so that one wasn't bad. And then the last one, since I was dealing with an average of 25, a sample of 25 cars, I'm going to use this information. So here's the difference, and this will be on your next exam, is if you're using if you're interested in a single individual, go up to the top. Just use the basic information. If you've got a sample, then you're going to do this, what we did here, this central limit theorem business. And here's the picture. Here's the terrible, why is this so messy? I don't know. Whoops, now it's all gone. That's a 5. So, there. But anyway, hopefully, I saw a lot of 5s on your answers. So anytime I see a 5, I think it's probably correct. And I'll mark it right. Okay, we do need to move on, though. So today, and I forgot, in all the excitement from last time, if you remember, we had this problem with I had my continuing problem with my computer crashing anytime I'm streaming. I don't know why that happens, but hopefully it won't happen today. But anyway, I forgot to tell you about daylight savings time. So we'll have to talk about that because I know we're still suffering, aren't we? We're all suffering. We'll get to that in just a minute because I have some statistics you can use. First, though, let us get started by dealing with where is my stuff? Why is it not here? Hold on a minute. No, we don't want that. Where's my new stuff? Just a sec. No, I don't want that. I want that. Just a minute. My new stuff is missing from this PowerPoint. I will find it, though. Give me a sec. It's got to be here somewhere. Maybe I stuck it in here by mistake. Nope. Where is it? Just a sec. It might be on my regular computer. This one? Come on. I just edited this stuff this morning. Must think I'm... Okay, I'm just going to have to do it from memory if I can't find this. Let me check one more place. Try here. Oh, thank goodness, I found it. I don't know why it's escaped. Why do I have so many versions of the same PowerPoint? That's the problem. Okay, give me a sec. It is, pick one randomly here. Which one do I want? I'm going to try this one, and if this isn't it, we'll do the other one. This is the one. So exciting. Okay, sorry about that. So, what we're going to be dealing with today is we're going to deal with the central limit theorem in regards to proportions. So proportions work a little differently than means. So this stuff is out the window. Well, it's not out the window. It's still here, but maybe I should just add to it. So we've got the central limit theorem for means right there. Here's the central limit theorem for proportions. It's pretty much the same idea. It's just that we're going to be dealing with proportions instead of means, so you can think of it this way. What if we were to all go out and ask 30 people who they're going to vote for president? And then we took the proportion of people who said that they were going to vote for, say, Roosevelt, and each of us had the same, had a different proportion, but we took all of those proportions and put them together into a big distribution. That's the idea behind a sampling distribution. I should say that we're never going to do this exact thing. We're never going to all take a sample of, say, size 50 and do the same thing with it. That would be ridiculous. What will happen is one of us, or maybe some survey company, will have a sample. They will ask a question, and then they will sort of theoretically imagine the situation where a whole bunch of people did that same thing, and then ask the question, how close are they to the truth? That's where we're going with this, and we'll get there next week, but for now we just need these formulas. It's really just this formula, because what is that? That is crazy, isn't it? So that's the one formula that we need to deal with today. But I'm just going to write these up here. So first of all, sampling distributions are normal, so normal. Okay, so this is for proportions. So we still have this normal thing. So as long as you have at least 30 individuals in your sample, actually it's a little bit more complicated than that with proportions, but we're going to ignore that for now. So we're going to be normal. The next thing is that the average of all of the sample proportions, so sample proportion, we're going to put a little hat, a little upside down V on top of the P to say that's a sample proportion. So each of us would have our own sample proportion, and we would each, contribute to the grand mean of all the sample proportions. So maybe I'd have 50%, and then Nathan has 40%, Jonathan has 55%, and so on. But we take all of those proportions and put them together into a mean, and that's what this thing is. That's the mean of the proportions, the mean of all of the sample proportions, and the mean of all the sample proportions tends to equal the true proportion. Kind of makes sense that if we each have our own sample, and each of us has, say, 50 people in our sample, and we compute a proportion, there are more than 30 of us. We're just going to pretend 30. So we each have 50 people, and then if we average each of ours together, all of our proportions, that's essentially the same as taking all of our samples and pooling them into one giant sample of 1,500 people and doing the proportion there. The larger your sample, the closer you are likely to be to the actual truth. And so that's why when you average together a bunch of sample proportions, you're tending to be close to the actual proportion. And then the other thing is this weird standard deviation. So this comes from the standard deviation for the binomial distribution, which we never went over, but doesn't matter, it's here. So that's the standard deviation that we're going to deal with. So let's see how we're going to use this. And so basically the rest of class, we have a bunch of practice. I am going to have up here, where is it? There. I'm going to be having Excel, just to warn you. So we're going to be toggling back and forth between Excel and whatever problem we're working on. So as promised before, we're going to play the numbers game. And the Excel that we do today is not a big deal. Next week, you definitely don't, let's see, which day is it? probably Wednesday. There's one of the days next week where we're going to do something in Excel that I'm going to want you to save on whatever device you have and keep it for, forever, because it is so helpful for doing homework, for doing any work that you do, or projects. Speaking of projects, we need some projects. Actually, I was thinking of that over break. I've got a project for you to do later. I'll explain. It's not that big of a deal. It's just like a glorified homework assignment, but we need to have something to put in the grade book. Okay, so here's what we're going to do is we have this problem here, and I want to identify all of the stuff in the problem. So I need to pick people, pick me. Give me a sec. So now I've got my random people here. And I'm going to first of all highlight all of the numbers. So here's one number, here's another number, here's another number. I think that's it. Yes, that's all the numbers that I see. So let's go through and try to identify them, and then we'll talk about how we're going to solve this using the central limit theorem for proportions. So first things first, Lana, what about that 5%? What do you think that's going to be? Oh, I should probably give you a bunch of options to choose from. We could either be P, or P hat, or N. What else do we have up here? P hat, N. Yeah, that's pretty much it. So which one would you like, Lila? The first one, P. It's the proportion of the, it says that its common assumption is that 5% of voters will vote for a write-in candidate. So this is what we believe to be true for the whole population. That's the population proportion. So that we're going to use the P for right there. So that's going to be P. All right, next one, 123. What in the world is that, Ty? Whoa, he's left. He's left the building. Rachel, you know what that is, don't you? It is N. Very good. So that number there is N. All right, now who's left? We got Shelby. Shelby, do you know what 9 represents? Yeah, so the P with the hat, it is sort of the P with the hat. It's actually not the P with the hat. I gave Shelby a hard problem to answer because 9 isn't any of those up there. But I can get the P with the hat from that 9, and Shelby knew that, and so she's like, well, we'll do P with the hat. So that one, 9, the way we would get P with the hat is we have to think in terms of what P with the hat means. The P with the hat is the proportion from the sample. So I need to turn this into a proportion. There's 9 people who voted for write-in candidates out of 123. That means the proportion in the sample is 9 out of 123. So far, so good. We can do this. Next, what we need to do is we need to take this and turn it into a normal curve. So let's go make the normal curve. I'm going to have to switch over here. N is 123. P is, okay. Okay, I'm just going to put this, I'm going to make a new, sorry to keep jerking you around here, there it is. Okay, so let me remind you what we have. We have 5% for P. N was 123. P hat was, that's a hat, 9 over 123. So far, so good? Now what I need to know is before I make my normal curve, well, I'm going to actually make my normal curve. There's my normal curve. I need to know what the middle of the normal curve is, so I'm going to have to compute mu sub x bar, or not x bar, it's mu sub p hat. That's what I thought. P hat. All right, so what is the average of this sampling distribution? I'm sure you can answer this, but so let me just pick someone out of the blue. Emma, what do you think the average of this sampling distribution is going to be? 5%, very good. There's no hat on that thing. It's just P, and so that's going to be 5%. I'm going to write it as a decimal because we need decimals in order to do the work that we're about to do. Okay, so that's going to be the middle of my normal curve, 0.05. The next thing I need to know is I need to know the standard deviation. Oh, I'm going to have to deal with that thing. Okay, I will do it, don't worry. The standard deviation of this sampling distribution. Oh, I should have put the sampling distribution down here, p hat. How's that? Anyway, that's going to be the square root of 0.05 times 1 minus 0.05 all over n. So this is going to require us to pull out one of my non-existent calculators and do the math on the calculator. So you can go ahead and do it, and I will just trust you. I'm not going to do it myself. I'm going to believe you, hopefully, and if enough of you complain, then I'll know it's wrong, whoever says it. I just realized I have Excel. I could just use Excel, couldn't I? But too late now. I was going to just pick on Hayden, because I'm sure Hayden has it, right, Hayden? Got that, lads? He's holding up the finger. Let's move out of the way. You can see it all. He's not liking his answer. You don't like your answer? No. Why don't you like your answer? It's far away from 1? I like it then. Tell me what you got. Square root will make it closer to 1. I'll give you a hint. 0.0. All right, while Hayden's thinking about it, I'm going to go type it into Excel and see if I can do it myself. So let's see. Oh, you missed your chance. I called on you and you weren't even here. So here we go. We did the square root of 0.5 times 0.95 divided by, how many, divided by 123. Does that look all right? There. Is this what you got, Hayden? No, you should, let's try that again. Is this what you got, Hayden? Yes. Hey, good job. Did I do it wrong? Someone doesn't like it? Oh, it's not what Hayden got. You were right the first time. Okay, let's fix this. Thank you for seeing this. Oh yeah, I did do it wrong. Hayden, you were right all along. I shouldn't have doubted you. Is that what you got? Yes! Thank you. Whether it's right or wrong, okay, it's what. So there it is. I like it. That's going to be sigma p hat is 0.01965. I like it. And so now let's go back to the original problem to see what it is that we are looking to answer here. Where is, oh, it's on my iPad, that's the problem. Because I need to do this and switch. Okay, so the question is, what is the probability that 9 or more of the polled voters voted for a write-in candidate? All right, so let me go back to here, back to that. Okay, 9 or more. What is 9 out of there? I need to know what that is. 9 out of 123. I think it's right here somewhere. You said 3-3? Okay, see, it looks like a 2, doesn't it? But anyway, so I want to know the probability that more than that proportion voted. So I know that this is a question about the number, but I can do this in terms of proportions. So I'm looking for that particular answer there. So to do it, I'm going to go back to Excel. I wish I could just move this over. Guess I can. Hold on a minute. There. Now I can see everything. Okay, so first of all, let's do this. Less than, just a minute, change this to less than 9 out of 123, and then I'll do more than 9 out of 123. So just to explain, since Excel can only think in terms of the left, I have to fool this. I have to fool Excel into giving me what I want. And so what I'll do is I'll just do equals norm dot dist of 9 out of 123. Look at that. I don't even have to know what the actual decimal is. So it doesn't matter what this digit is, because Excel is going to compute it for me. So 9 out of 123. The mean was 0.05. The standard deviation was 0.01965. I truly want to know the answer. And that's what I got. Hold on a sec. So that's the answer for less than. That's this stuff over here. Once I get the right thing. That is the 0.88. So to get the stuff on the right side, I just have to do equals 1 minus that thing there. And that gives me the stuff to the right. So this is 0.11916. Does that look all right? Did I get all my numbers right finally? Yeah, keep me honest on this, hopefully. Okay, let's see what our next thing is. Okay. It's time for statistics you can use. So, this week, we had to endure this time change, didn't we? And there is mounting data that demonstrates that time change kills people. Literally kills people. For example, right here, a group of researchers back in 2020 did a study on a large U.S. registry, including 732,000 fatal motor vehicle accidents, and found that the fatal motor vehicle accident risk is increased by 6% the week after we spring forward. Tragic, isn't it? Well, it's not just danger on the roads that you have to worry about, but you also have to worry about danger when you go to hospitals and other places. And so this study, which was done back in 2021, examined the time change in relation to safety-related incidents in hospitals. What is that? Well, it's when someone's supposed to get 1 milligram in morphine and they get 1 gram of morphine, or something like that. I know that would never happen, but whatever, it's making mistakes of that nature, something that was deleterious to the patient. So here is the conclusion, is that over 8 years, they found that there was a 4.2% increase in safety-related incidents during the fall time change, and an 8.8% increase during the spring time change. This is for the week after the time change. Dangerous time to go to the hospital is right after the spring time change. But interestingly, even the fall time change, you end up with an increase in safety-related incidents in hospitals. And so this is why I say that the time change kills people. Oh, I'm sorry, I think I was pointing at the wrong one. Oh, it's 18%. 18% after the spring time change. That's it. And then whatever, 4.9% after the fall time change. So, this, you put the wrong drug into someone, they could die. So anyway, a number of years ago, actually you can probably tell by the swag I have developed, I thought we can conquer this. We can get, we should abolish the time change. And so I came up with this little logo that we can use. And I have some merchandise that you can purchase. So you could get the T-shirt or the ball cap, or maybe I could license this to Stanley Cup, to get this. I know it's not a Stanley Cup there, but whatever. And this was right after the pandemic, so I had masks that you could buy. But anyway, on a more serious note, I thought that we had won at one point because in 2022, Marco Rubio, pushed through the Daylight Savings Protection Act, and I thought that we had won, but unfortunately, it didn't pass the House of Representatives. But I love these quotes from Rubio. He says, I'm not a big fan of like the Republicans that are in charge of the country, but I love Rubio now. Look at this. He says, we don't have to keep doing this stupidity anymore. My sentiments exactly. Why would we enshrine this in our laws and do it for so long is beyond me. And this is actually, this past 2 weeks ago, he said this, he's quoted, we are springing forward, but we should never have fallen back. My Sunshine Protection Act would end this stupid practice. I love his use of the word stupid all the time. Anyway, it is stupid. It's ridiculous. So here's what you can do. So this Sunshine Protection Act is still on the books. It still has passed the Senate. It is still not through the... I contacted my congressperson and Nancy Pelosi back in 2022, and they did nothing for me. But now you can because you're youths, and people want to, cater to the youth vote, right? So contact your House of... I could put this on our webpage maybe, and I even have text for you. So I'll put this up on our webpage so that you can just click a link and then copy and paste. Here's what you should say. Please vote yes for the Sunshine Protection Act, H.R. 69. This is a rare issue that is everyone can agree on. Literally, it is bipartisan. Changing our clocks twice a year is not only disruptive, it increases deaths on our roads and reduces worker productivity. There's, just in a nutshell, okay, I think I am done for now with that. Let me move on to something more mundane. Practice. So I will make sure I put that on our webpage so that you can click and do it. Yes, you clicked?
I have a question.
Yeah, what's that?
Okay, back to the sunshine protection thing. I understand like changing the clock back does disrupt productivity, particularly during the time within 18 hours before and after it.
No, it's a whole week after.
Oh, a whole week.
The whole week. People are dying.
Oh,
People are dying,
that
and
just makes it
the blood
easier.
is on your hands.
So here's my proposal. 2 times a year, there is a week called bank holiday. Just
Okay. No, we just have to do away with the time change. That's the easy thing. No, the thing that I thought that Easton was going to do is he was going to complain about standard time being better than daylight savings time. We're in daylight savings time now. Standard time is winter time. I don't care. Just stop the time change. I don't care if we're in summertime or winter time.
Yeah.
Okay.
I agree with that. It's nice to go home when there's light out sometimes.
Yeah, so you want to have winter time or summertime. I don't care. You pick. You pick. I'll go along with it. Okay. Yeah, you know how much pain you were in on Monday morning? Okay, I need to not be a politician, do I? Just stick to my, my lane here. Yeah, I'm a statistician. Just 12% of students transfer students. Small universities, total undergraduate students number 1,265. What's the probability that between 100 and 200 students are transfers? Let us get our numbers. Back to numbers. Okay. Let me just check my blood. Yes, I see I have elevated heart rate right now. Okay, we're going to be okay though. Look at this. We are up to Clayton. Clayton, what in terms of all of these beautiful symbols would 12% represent? It is P, very good. That's a proportion for the population. P is 0.12, good. Next, we need another volunteer. Who is next? Kira, what is 1265, 1,265? What does that represent? So of these symbols up here.
Oh, sorry, I was wrong for like last 10 years.
Yeah, it's all right. You can do it. It's a quantity. In, very good. I knew you'd get it sooner or later if I kept. Anyway, 1265, so good. Now 100 and 200, those are sort of related to one another. Luke, do you have any ideas? What's 100? The P with the hat. It's not exactly the P with the hat, is it? No, it's not, but it's related. So we would do something like this. The p with the hat is 100 over 1265. Same thing goes with the 200. I'm not going to bother anyone about that. That's also a p hat. Those are sample proportions. So now I need to answer this question. 12% of students are transfer students. We have the p. I know what we need to do. Before we move on to Excel is we need to do this. Mu sub p bar is equal to what? And then sigma, I'm going to have to erase this over here. Sigma sub p hat. So I need to have the new mean and the new standard deviation. So first of all, the new mean, it is so easy, I think Liberty can do it without even thinking. Liberty, what's the new mean? .12. Very nice. It's always going to be the same. Notice over here, when you're dealing with the means, the new mean is the same as the old mean. Here, the new mean is the old proportion, but whatever. We're dealing with proportions, so we have to do it that way. Okay, now for the hard one, sigma p hat. I'll write it out, and then you're going to have to type it in because apparently you can't trust me to do it correctly. So 0.88 all over 1265. Although I've learned that I can't trust some of you to do it either. I see people busily typing. I've already seen who the next rando is, so I'm just going to wait until that person finishes typing. Type, type, type. Easton, you got it? Wait, can I trust you? Well, let's hear it.
Okay, 0.00913, and mine continues to 66439.
Okay, I've run out of room here, so I'll just write that if that's all right. I know, it should be a 7 there, but you get the right idea. Does anyone complain about Easton and his calculator ability? All right, because I didn't do it, so that's the only reason I ask. Now let's go ahead and take a look at what this picture is going to look like. Notice that I want to know between 100 and 200. And so what I'm going to need to do is I'm going to need to draw my picture kind of like this. Getting really bad at this. So 0.12 is in the middle. I'll need to actually compute what is 100. So 100 over 12, what was that again? 1265. Glad I checked. So I'll do 100 over 1265, and that'll give me 1265, 0.79, and then I'm going to do 200 over 1265. And I know you could do this on your calculator, it's fine. So then this is going to equal 200 over 1265. And there it is. So 0.79 and, I'm sorry, 0.079 and 0.16. So over on my diagram, 0.079 and 0.158, whatever. And so here is the area that I'm interested in. So draw the picture. I know that Newton says you don't have to draw a picture. Newton doesn't care the way I care. I care about your intellectual development. So draw a picture, it'll help you. And you'll do better on the exam because of it. In fact, I'll make you draw a picture on the exam. You did it on the quiz. Look at these beautiful pictures. Beautiful. Oh, not so good. Beautiful. Okay, so most of you did a good, beautiful job there. But let's go ahead and see if we can do this. So to do this, what I'm going to do is I'm going to separate this into two pieces. The first one is going to be less than 0.158. The next one will be less than 0.079, and then I'll subtract the two from each other because remember, Excel is leftist. So we're gonna do this one first, that'll be the whole thing, this one second, that's just this little piece. Subtract the two, and you'll get the answer we're looking for. Phew. How did the time go so quickly? Okay, so this is gonna equal norm dot dist of 0.158. Where are my numbers? 0.12 and 0.009 and some other numbers. Give me a sec, I'll find them. Where did they go? Oh, I know where they are. They're on my iPad. Hold on a sec. 9136. Okay, 9136. True. I think I got that right. Wow, it's so close to 1. It's almost 1. Maybe some of you it is 1 because you've got fewer digits showing than me. Now I'm just going to copy this and just change this one number right in here from 0.158 to 0.079. Wow, that's even smaller. I didn't realize it would be this small. And then I subtract the smaller one from the bigger one. So big minus small. Whew. Okay, I should explain this because this is going to pop up. So, not all the time, but every now and then we're going to see this. Does anyone know what that means? You know what it means? What does it mean?
Well, you move the decimal point further than you from the 6, so for that -6, you move it to a 6, and it would cause a
That sounds really technical. See, when I look at this, here's what it means. It means it's an extremely small number. See, E means extreme, minus means small. Actually, what Grayson said is perfect. It is exactly true. It means this number times 10 to the -6, but you don't have to think in those terms. All you have to remember is that this is extremely small. So that's all that really matters. So my final answer is down here. I don't think you'll see that in this homework, but you might in future homeworks, the E thing. Wow, everyone's leaving, so I guess I'm done too. Have a nice day. You know, you get the day off tomorrow completely, don't you?